Welcome. Today we'll solve a challenging problem involving implicit differentiation of an equation with variables in exponents. Let's start with our question. Given the equation x to the y times y to the x equals 1, find dy dx. Since we have variables in the exponents, this is a perfect candidate for logarithmic differentiation. Let's start by taking the natural logarithm of both sides. Using the logarithm property that the log of a product equals the sum of the logs, we can split this into two terms. Next, using the property that the log of a power equals the power times the log, we get y times log x plus x times log, y equals 0. Now comes the tricky part. We need to differentiate both sides with respect to x. Remember, y is a function of x, so we'll need to use the product rule and chain rule. Let's apply the product rule to each term. For the first term, we get y times the derivative of log x plus log x times the derivative of y. For the second term, we get x times the derivative of log y plus log y times the derivative of x. Now, let's simplify the derivatives. The derivative of log x is 1 over x, the derivative of x is 1, and the derivative of log y is 1 over y times dy dx. To solve for dy dx, let's group all terms with dy dx on one side and all other terms on the other side. After rearranging, we get this intermediate form. Finally, we can simplify this expression further. Our final answer is negative x log y plus y all over y log x plus x times y over x. This problem demonstrates the power of logarithmic differentiation when dealing with complex expressions involving exponents. The key steps were: first, taking the natural log of both sides; second, using logarithm properties to simplify; third, using the product rule and chain rule to differentiate; and finally, solving for dy dx.